Hello and welcome back. And when we left off, we realized that AAA was not a condition. And by AAA, I mean we have three pairs of congruent angles. But yet the triangles are not congruent. So we wrote they are not. And now, how about this situation? SSA, side pair, angle pair. And you might be thinking, we've seen this already. Side pair, angle pair. Yes, but this angle is in between the two sides. This angle is connected to both of the known sides, the single mark side and the double mark side. Kind of locks in the triangle right there. This one is different. This angle could change. All we know is that this matches this matches this, and then this angle over here is locked, but this line can go on much longer, which ends up making some interesting situations. Okay, here we go. Oops, that was supposed to be double mark. It's kind of sloppy. And then the angle we know. Okay, point to point. Ting. Rotate. Hey, no reflection required this time. Okay, does it line up with the triangle underneath? No, this is not lining up. Did I do it right? The single mark is on the single, or this sloppy double mark is on the double mark side of the other triangle. This angle mark is on the angle mark side of the triangle. This single mark is on the correct side, that top side, but the top sides are not the same. So, for the given criteria of side, angle, no, the triangles are not congruent. SSA does not work. Having two sides and an angle, but not the angle that's in between the two sides, is not good, or is not sufficient. If we did have the angle in between the two sides, that is sufficient. It locks the triangle in. This triangle is not locked in. It's the one that doesn't work. And just like AAA doesn't work, this one doesn't work. Now, this one spells a bad word if you spell it backwards. So make sure you always do the sides first and then the angle at the end. And because it's kind of a naughty word, you can remember that it doesn't work. But I do want you to know that it almost works. What do I mean by that? Well, there's actually only two options in this situation. Well, first of all, let me check, did they lie? No. This side with the single mark is the same length. Is the angle match? Yeah, the angle matches. What about the double mark side? Yeah, it's the right length. So what happened? Well, it turns out that this angle's locked in, so this line has to be there. But this angle's not locked in. So this arm could be way out here. The problem is if it was way out here is that it doesn't complete the triangle. But there are two places where it does complete the triangle, there and there. Okay? You could swing this arm around, rotate it around this point. There's two places it would hit this long arm that's locked in, there and there. So SSA almost works. There are two possible triangles. And here's another explanation of that. If this angle was locked at 30 degrees, so I can't change this angle, so this set line has to go forever. This line would go forever, except I do know it's 22 millimeters. So I have an angle and a side, and I need one more side. The last side, we will say, is 1 centimeter, 10 millimeters. So it's possible this last side could have any angle, but it has to be exactly 1 centimeter long. So it could be here. That's 1 centimeter. But it could also be over here. This is also 1 centimeter. So you could either have this looking triangle or this bigger one. It's like a swing. This side can swing back and forth. Now, if it's in this section, it's not making this right triangle because it has to be 10 millimeters long. And if the 10 millimeter side is sticking out down like this, then the actual side of the triangle is less than 10. If it has to go all the way to this point to be 10. So, but there's two spots where it actually hits exactly at 10 millimeters. So this was side, angle, and it's no guarantee that the triangles match, but it's close. And in fact, you can explore conditions for certain angles it would work, but for 30 degrees, certainly it doesn't work. Too many possibilities. Well, specifically one extra possibility. No. I mean, they're not congruent. So they could have been, but they're not. No guarantee. Last situation. When we know that there's a pair of sides, a pair of sides, a pair of sides, that is called side, side, side. Or SSS situation. So the little nickname is SSS, side, side, side. Will this work? If I was standing out in a field and I measured 3 sides on a triangle and went somewhere else in the field and measured another 3 sides on a different triangle, but I used the same measurements, let's say 7 feet, 10 feet, and 12 feet, and this one is also 7 on the triple mark side, 10 feet on the single mark side, 12 feet on the double mark side. Are those triangles going to be the same size, same angles? If I translated one and transformed it onto the other, would they line up exactly? Well, let's find out. At least in this case. Okay, I'm going to see where the single and the double meet at Q. Well, they meet at B as well, so let's take B to Q. Let's rotate around until that single mark side is lined up with itself. Then reflect over and dink. Is it landing perfectly on? Yes. Nice. It works. Yay.